ready to go. All right, slicer settings, deep dive. I guess I'll just get right into it. So I started putting this together, and I was going to just do basically the expert settings or maybe the level 2 settings here. And then Shashi asked me to go ahead and get into some of the basic settings here, just because we have some people that haven't used much in the 3D printers much. And as he said, there's a lot of people here that are probably more qualified than I am to do this presentation, but hey, you know, somehow I got picked, I don't know. All right. I guess if you get any questions along the way, just raise your hand or interrupt me. So I stuck all the basic settings on one page. Just gonna go through them really quick. Does everybody here know your basic settings, or does anybody here just not have a clue on basic settings of your, or are you interested?
We have a couple people who are relatively new.
Okay, all right. So I'll just go through this really quick. So the first setting that you're going to want to see, the most basic setting, is your layer height here. That right there, you know, defines how high up the print head moves when you do a Z transition. And the next setting here, well, I guess going back to that layer height. Typically, if you don't know what to use a 0.2 millimeter setting. That usually works for most things. Yes, John. I'm sorry?
Your very first layer, what do you recommend? We're usually just set 1, 2.
So your very first layer height, I'll get into that in a little bit, but your very first layer height, it depends on how much adhesion you need and how level your bed is, but I usually go through about 0.15 millimeter for the first layer height. 0.2 works. I never go 0.3 because you get layer adhesion problems, or plate adhesion, I guess. Okay, solid layers. The next thing you're going to look at here is your solid layers. And so the top and bottom of your print is going to be solid. I usually try to do at least 4 solid layers here, no matter what my layer height is. And if I got a thin layer, or I got 0.1 millimeters or 0.05 millimeters, I'll do up to 10 solid layers there, just to kind of give some strength to the part, because the part gets a lot of strength from this. Your shells or your walls, depending if you're from Simplified 3D or Cura, those are going to be set at usually 2 or 3. If you get too many there, you can have warping problems. And then your infill and your density, there's a lot of changes you can make here. But if you don't know what you're doing, your default setting would be 20% on this. If you need stronger parts, we can get into that, but that's your default setting. So, except for like on this part here, which is this is part of that Rodin exhibit. On here I used 2 shells for that. I mean, not 2 shells, I'm sorry. I did 2 shells, but I did 15% infill on that. A raft, you shouldn't almost never need to use a raft. There's rare instances where you need to use a raft, like if you're printing polycarbonate. But if you don't have your bed level, you can use a raft, and then that can help even out your bed. And then you can do your first layer on the raft. They're hard to remove. They don't create a great surface. I really don't see any need for it in most cases.
If you're running a MakerBot, you should always use a raft.
A MakerBot should always use a raft? Yeah, I don't know. I've never ran the MakerBot, but
Real quick. Can you talk about the printers that you have?
Yeah, printers I have. I have a FlashForge Creator Pro. I have 3 of those, plus a QD Tech, which is a knockoff of that. And then I have an old ANET A8 clone. It's actually M505. And then I have a Folgers Tech FT5, a T-Rex 2 Plus, a T-Rex 3, and I think that's it. I got rid of my other printers. I think I'm down to 9 or so. Anyway, I went through last year when I was doing my taxes, and I had to figure out my energy usage and all that, and so I figured out my hours. And I had right around 12,000 print hours last year. So I had a bit of an energy bill there. It was about somewhere around 600 kilowatt hours per month. Maybe that's wrong. I don't know. I can't remember that number. It was expensive. It was significant. Okay, so I guess if you have a MakerBot, use your raft. Otherwise, you should be able to tune your printer up to not use the raft there. So support material. If you don't know what support material is, this right here is support material. And this is what it looks like with the support material removed. On that there, if you don't know what to use, choose 20% for your support material. Skirt or a brim. I typically don't use a skirt or a brim, but I have specialized startup scripts in my G code that will do a purge for me, so I don't need that. But it's a good idea to do a skirt at least around your part, just to purge out material that may have gotten a little bit hard, crystallized in the nozzle, overheated, whatever. Or sometimes it's just not ready to print. The brim you can use if you have problems with the part warping up off the print bed. Typically you don't need to use that unless you got some weird part in ABS that's really big. Bad stories there.
For the new users, what's the difference?
Okay, so the skirt, so new users, the skirt goes around the part, doesn't actually touch the part. The brim will actually touch the part, and you can have several, what do you call it, shells or outlines around that. If you are going to use a brim, I'd recommend using 10 to 15 outlines. If you don't use enough, it doesn't help, and it's also harder to get off versus 10 to 15 outlines. They just kind of peel off if you do that. Also, if you're going to use a brim, I'd recommend going with a 0.1 or 0.15 millimeter layer height. And I don't think you can use it with a raft. I don't know. I've never tried using it with a raft. Extruder temperature. This is going to vary depending on what material you have. If you're just starting out, you're probably using PLA. So somewhere around 200C to 215C is going to be your starting point on that. 215 if you need strong parts, 200 if you want them to look better. And then your bed temperature, either 0C for PLA or about 50C for PLA. And then speed. If you don't know what speed to use, question up top.
When do you turn off your bed temp?
So the question is, when do you turn off your bed temp? I never turn mine off. I use a glass plate for most of my printers, and if I turn off my bed temp, the print will pop off the glass while it's printing. So whenever I turn it off when the print is done. Okay, so speed here. If you don't know what to use, pick 50 millimeters per second. You can go up or down. You can do calibration cubes and whatnot if you want to mess with your speed settings. And then cooling. For PLA, well, for anything, you always have the first layer, the cooling is always turned off. And then after that, for PLA, you're going to want to have it turned on anywhere from 70 to 100%. Usually PLA does not have a problem with too much cooling. ABS, you never turn it on. There's all kinds of settings for different materials. I'm not going to get into that here. But that's probably more on, I don't know, that's a different topic. Oh, I have 60 millimeters per second here for the cooling I get, or for the speed, and then the fan off of the first layer for the cooling. But yeah, that's your very basic settings. If you don't know anything else, go and set these guys up, and you should get a decent print off PLA. Any more questions? All right. Sure. Question is, what's your bed material? I use glass for most of my printers for bed material. There's one printer I use a PEI sheet, and it's a long story, but I'm too lazy to change it out.
No hairspray?
So the question is whether or not I use hairspray, and the answer is yes, sometimes. If you
Your hair looks great.
So, if you don't know, you can use this Aquanet unscented super hold or mega hold or whatever it's called, the purple can of hairspray on glass. It can act as help adhere to the bed, but really what it does more than anything else is it acts as a release agent as well. So if you're printing PETG, and you try to print it on really clean glass, as that print cools, it will crack your glass, it'll pop it off, bad things happen. In that case, hairspray acts as release agent. For PLA, I usually just print on a clean bed. TPU, I'll print on a clean bed, just super clean, wipe it off with isopropyl alcohol. And any oils on there will cause you to have bed adhesion problems. You can spray hairspray on there if you want, if it makes you feel better. You can also use Elmer's glue on that too.
Elmer's?
Elmer's school glue, the glue stick,
Oh,
purple glue stick.
So when you're using adhesives, is there any way to preserve the nice glass-like finish? Because when I've done it, it screws up the finish.
So the question is, if you're using adhesives, is there any way to preserve the glass-like finish? And the answer is yes. You just, like the hairspray, you just need a very quick, really quick spurt across the printer, just a very light. You're using it, like I said, more for a release agent than you are for adhesion.
Okay, so I'm using too much then.
Yeah, it's possible, yes, you're using too much. If it's messing up the finish of the print, you got too much on. Okay, so the next topic here is your profile. So you start going in and you start messing with all your settings, and you forget where you were. Both Simplify 3D and Cura have profile settings, and the slicer with the three. Every slicer basically has profile settings. I forgot to mention here that there are a ton of slicers out there, and excuse me, I had to pick a couple to use. Excuse me. Anyway, okay. So I had to pick a couple to do this presentation on, and so I chose Simplify 3D and I chose Cura because they seem to be some of the most popular slicers. And they're the ones I'm the most familiar with. Doesn't hurt. Anyway, okay, so your profile settings. In Simplify 3D, you can export them, and I recommend exporting them often because Simplify 3D stores all the profile settings in the registry, and it can and it will get corrupted after a while. And there's no way to recover from the corrupted profiles other than deleting everything and starting over. And you can also import. So I probably have 100 different profile settings, and for Simplify 3D, you're limited to a certain number of settings. So if I need to, I'll just take and delete a profile and then import a new one as needed. In Simplify 3D, it has an auto-configure material, and that sets only the temperature. It also has an auto-configure quality, but that only sets the layer heights plus the top and bottom layers. And then it has the auto-configure extruders, but that just changes your scripts. So there's a lot of other settings that don't get changed. So Cura has similar problems. You can't really import and export the settings, but you can save it as a project and export and import projects. When you do that, when you change the settings, sometimes you'll override material temperature settings and the speed settings on that. And what I've found is that you can't go back if you do that sometimes. It doesn't ever, we change materials and it never updates your temperature or your speeds. So it doesn't really work as it is intended as far as I can tell. So what I recommend there, both with Simplify 3D and Cura and anything else, is that you have a profile set up for every type of material that you print with. Some people have profiles set up for every layer height they print with. Some people have profiles set up for, well, plus you have for every printer you print with. But you can end up with a ton of profiles. Any questions here? Okay, so if you buy Simplified 3D, which I really don't recommend you do anymore, just because if you own it, it's worth using. I don't think it's worth buying right now. People can argue with me on that one, but I think all the other slicers out there have surpassed Simplified 3D. Maybe when they come out with 5, but
I agree 100%.
I don't think I'll buy 5 though. But anyway, if you do have Simplified 3D, it's a decent slicer still. You want to turn on the Show Advanced, and then in Cura, now I have saying check all. You're going to want to go back and undo that because it'll really slow down Cura if you do that. But if you want to see everything, you can check all on your setting visibility. And then on Simplified 3D, you want to go in millimeters per second because that's what everybody talks in. And then turn off your automatically scale and your automatically center and arrange. The reason you want to do that is that sometimes you get parts in there that you don't want scaled and they come out too big. And then sometimes you get parts that come in as part of a set that you want to maintain the relationship between that part and other parts. So you can always take and place some and arrange them on the platter later, but you can't undo this if it does it for you automatically. All right, any questions here? Yes.
So when you're checking all on the Cura side of this, what is the visibility that we're looking at? And is that the layers and the travel and all of that stuff, or?
So the question is, when you check all, what do you check? And there's I don't know, there's over 100 settings I think that you're basically making them all
So
visible.
It's the setting visibility.
Yes, it's the setting visibility that you're doing. Like I said, you're gonna eventually want to uncheck the ones that you never use because it's a Python script that updates that, and it just makes the whole thing really slow. But if you want to see everything, you can check all. And I realized quickly that I'm not going to go through every single setting that they have in Cura. All right. Okay, so now we're going into our level 2 settings where you start getting a little bit more configurable. Say you upgrade your printer, you got to change your nozzle diameter. If you change your nozzle diameter to 0.6 for some reason. But usually that's a 0.4 millimeter on most printers, unless you got a oddball one. Extruder multiplier. Now this one is kind of an interesting topic. Some people will tell you to tune your extruder multiplier when you're going through your calibration. What I found is that it should almost always be 1.0. And the reason being is that you have a filament diameter that you can change to tune your prints. You also have a step that you can set in your firmware to tune your prints for calibration. And what I found is that if you accurately measure your filament diameter, it's going to output the correct amount of filament for you. If you have your extruder calibrated, your diameter calibrated, then your prints are going to turn out properly. The question?
As a beginner, I thought I saw some symptoms of insufficient extrusion at high moving speeds.
Mm-hmm.
Is that something addressed here, or is that?
So insufficient extrusion at high moving speeds, I get into that a little bit.
Okay, I can wait then.
But that's probably, if you're going too fast, you probably don't have enough thermal mass to keep up.
Can you turn up the temperature?
You can turn up the temperature to solve that. You can upgrade your extruder heater if you go with a Volcano or something like that. It just depends on how fast you're talking about going.
Yeah.
Usually a standard extruder can do up to about 125 to 130 millimeters per second.
I was significantly above that.
Okay, so you're probably going to need to either go a smaller nozzle or increase your thermal mass of your heater.
I mean, I was trying to get a print done in less than a day. But nobody ever cares about that.
Yeah. Question here?
Yeah, with regards to Cura, and the almost always 1.0 on the extruder multiplier. So when you go in and you create a profile for a particular filament, you actually measure the diameter
Right.
That basically should take care of, I've almost convinced myself with Cura with the feed prints that, like, okay, I jack it up to 105%, that looks great.
Right.
And I still got the same diameter, but, so
Cura should go and look at that and use that, make that correction. What I've seen is that it seems to, I'll be honest, I don't use Cura nearly as much as I do Simplify 3D because it's so slow. But it should, in theory, it should honor that number. It seems to.
What do you mean by, two questions. What do you mean by slow in Cura? Slow print or slow slicing time?
So by slow in Cura, I mean that it's slow to update the screen, it's slow to slice, it's slow to...
Okay, just the running.
It's running a Python script in the background.
What strikes me is a lot of extra motions on Cura. We'll print something here, and then it's over here, but there's stuff in between. It could have printed out its way over.
Yeah, I don't know the slicer behavior that well on Cura.
Now,
Simplify will do that. All the slicers will do that.
okay. Nozzle diameter.
Yes. Nozzle diameter.
Is there a lot of variation coming out of the factory when you buy 0.4s really putting out 0.5 or something?
So the question is, there's a lot of variation.
Is there?
And I don't know if you're buying them. If you're paying $2 a piece for a nozzle, probably. If you're paying $10 a piece, probably not.
Okay, because I've been measuring the filament that comes out.
Yeah, so you can't always depend on the filament diameter that comes out because that depends on your temperature and your speed and your material.
Okay. And what are the reasons to deviate from the 0.4 millimeter? Can you talk about that, or is that something?
Sure. So there's people that have very large printers that can do, yeah, 20 inches cubed. They can do. We have one in the club that can do a meter by a meter by a meter, and if you're going a 0.4 millimeter nozzle on that, it's going to take forever to get a print done. We're talking a week or more. And so if you go to, say, a 0.8 or 1.0 millimeter nozzle on that, you can put out a wider track, you can put out a higher layer height, and you can get your print done quicker. It doesn't look nearly as good, but something that big, it's a trade-off, right? But to get to those bigger layer heights, you better put a volcano nozzle on there, or else print really slow. I'm sorry? Yes, you need the right extruder behind it because the extruder probably won't be able to keep up.
And how about on the fine stuff?
I'm sorry?
Then how about going to a smaller diameter?
So a smaller diameter, if you have really tiny prints, you can go with a smaller diameter. I think the smallest I've gone with is a 0.1 millimeter, and I went with a 0.025 millimeter layer height. It goes very slowly. But you can make some really tiny parts. I wouldn't do it in anything other than PLA though.
Why not?
ABS just doesn't behave right, and I don't know. I wouldn't try. You couldn't push TPU through that nozzle. I don't know. I haven't tried any of the other materials, but I don't think I would. Usually something that small doesn't need to be strong. It just needs to look good. All right. So retraction distance here. Unless you have a Bowden extruder, I found that you generally don't need anything bigger than 2 millimeters in your retraction distance. Other people will have different experiences, but that's what I found. And there are ways to actually eliminate retraction, but we can get in that in a bit. And then this retraction, which is the vertical Z-hop. So if you're taking and moving from one print to another, sometimes people turn on what's called a Z-hop. And they'll do that so they don't hit parts as they go by. The problem is that whenever that extruder picks up, it's going to leave a little tiny wisp of plastic behind it. And then you're going to be able to see that. If it's on the top, you're going to be able to see it. Sometimes you'll see it coming off the side. So I usually have it turned off. The other time I've used it, I think it was about a 12-inch tall print. It was super thin, skinny, and it was in TPU. And every time that nozzle even came up to that print was flexing back and forth. And I really don't know how it finished, but it looked good when it was done. But I turned on Z-Hop for that. And then retraction speed. So most people don't realize this, but it's usually, that retraction speed is usually hard-coded into your firmware somewhere around 25 to 30 millimeters per second. So you can put it at 70, 100, whatever. It's not going to do any good if it's hard-coded at 30. Some people turn it up because they think that you pull that filament out and it kind of creates this big giant suction and it sucks the filament up. But what really happens there is that you pull it up so fast that it actually ends up leaving filament behind, and it can make it worse. All right, any more questions here? Okay, so now we're getting into some of the settings that are similar between Simplify 3D and Cura. And sometimes Simplify 3D has them and Cura doesn't, and vice versa. So the first one is this print island sequentially. I couldn't find this in Cura. I don't know, does anybody know it's in there?
It's in there, yeah.
Okay.
I know at least ultimate makers allow it.
Okay, okay. So I guess it's in there. What that does is if you have multiple points on your print, or if you have multiple prints, it will take, and instead of optimizing the flow, so if it goes through and does 1, 2, 3, 4, and then it'll do 4, 3, 2, 1, and that helps you print faster, it'll actually go through and do 1, 2, 3, 4, or whatever order it decides, and it'll come back and do 1, 2, 3, 4. And what that allows you to do is it allows a little bit more cooling time on that part before you print the next layer. And if you have a really small part, it can help with the quality. Most times you're going to have it turned off.
What are some other names for that in other slicers?
Which
And
setting?
the print island sequentially,
One at a time.
one at a time is another. Okay, is that what it's in Cura? Is one at a time? Okay. I saw one at a time, and when I read the one at a time, what the description said to me in Cura, as I recall, was that it'd print the entire object and then move on to the next object.
Yeah, that's the way I understood it.
And that's not what this does. This one will take and do everything on the layer, but instead of going and doing the same part twice when it gets to the last part, it goes up a layer and then stops, it'll actually go back to that first part and print. So you always have the equal amount of time between each layer on each part.
Even if the part's short?
I'm sorry?
Even if the part is short? I mean, you've got the parts.
Okay, so the question is even if the part is short, and yeah, obviously if you're finished printing the one part, it won't go back to that one anymore.
But does it insert time?
It does not insert time. There are other settings to make it insert time. It's in the cooling tab of Simplify 3D, and I can't remember what it's called in Cura. There's layer time in Cura, right? Yeah. Minimum layer time, right. Okay, so we have the outside in versus the inside out, or we have outer before inner. And what that allows you to do is sometimes you want to print the outer shells first. I'm trying to remember. Oh, if you want higher accuracy parts, you can print the outer layers first, and then when you measure them, they're gonna be a lot more accurate. Well, within a degree, versus if you print the outside first. But in general, you're gonna get better quality on it if you do inside first. Especially if you have overhangs or anything like that.
What kind of accuracy can one expect out of these printers?
The question is, what kind of accuracy can you expect out of one of these printers? And I think 4 microns is probably is what the 1/16th of a step setting. That's generally what most printers claim is 4 microns.
Well, I mean, practically speaking, if you make a part that's gonna be 20 millimeters long, can you expect that to be 20 within a 10
If-
millimeter or?
If I make a part that's with, I usually can get within about 0.25 to 0.5% accuracy on the length.
Within what?
0.25 to 0.5%,
Okay.
unless it's a really long part, and then I can get, the accuracy can be higher. It's actually very accurate. A 20 by 20 millimeter cube, I usually measure 19.98 between that and 20.02.
Okay.
That's what I shoot for if I'm doing a calibration cube. And after that, it gets into the accuracy of your calipers, quite honestly.
Now, does that change with material that you have to recalibrate for different materials?
Yes, you have to recalibrate with different materials. ABS will shrink at about 1%. PTG will shrink about 0.5%. PLA I use as it will shrink, but I calibrate for 0 shrinkage there. Nylon will shrink. Sometimes you just have to do a test print and figure out how much it's going to shrink. But there's definitely shrinkage on your materials that you have to compensate for. And sometimes you have to print a part twice, or 3 times, or 4 times. Never had to do that. Okay, vase mode, spiralize. This is a mode that I honestly have never used. I've looked at it, it looks cool. I've never printed a vase. But what it does is it goes along, and instead of doing incremental layer height, it'll as it goes along, it'll gradually increase in the layer height, so you got one continuous strand all the way up, which is pretty cool when you think about it. But yes, question?
I use the base mode in the Prusa slicer to move that cone. And,
Right.
It doesn't actually increase gradually. It went around twice and you get a little bump. So if you look at it, there's a spiral of joints all the way up it. It works its way around. I thought I put the checkbox on it.
Yeah, this is, like I said, this is one mode I've never actually used. That's what the description says. I'm gonna go with that. I just never had the need to make a vase.
I've used it for printing very thin wall parts that
Right.
essentially just a single one.
Mhm.
And if you try to do it in layers, you've got witness marks.
Sure.
And gap. When you print base mode, it just grind up.
Right.
Beautifully smooth, wonderful part.
And you can actually use vase mode. I have turned on vase mode once in a similar situation where we had thin wall parts,
Yeah.
and it will work, and will stop and start too. It didn't work out for another reason, but
If you have a
Adam?
large diameter nozzle and you're using base mode, then it's quite effective.
right, yeah, that's what I've seen. Is large diameter works well with vase mode. You can get insanely good overhangs too with large diameter nozzles. Okay, so there's start points. And Cura and S3D have 2 different ways of doing start points. So in Simplify 3D, you got a random one, which I don't recommend. You've got the closest, which basically is going to say the closest corner that it can find, inside or outside, it's going to align to. And that works most of the time. And then the last case is a specified location, and you do an XY location, and it'll always start closest to that XY location. I've done that effectively. I actually had to make a vase for a local company. It was thick-walled, though, not a thin-walled vase. And they had a ridge that came up one side of it, and I hid the Z-seam on that, and it actually worked out very well. With Simplify 3D, it's kind of a bug in that you can only pick one point, even if you have 3 models. So where there I had to do three different copies of this, I had to spin them all and make that seam all point to the middle, and I just picked the middle of the bed for my point. On Cura, they handle it a little bit better. They have either random or the shortest distance or a specified location, or you can do what's called the sharpest corner. And that it also couples with this seam corner preference, and they have hide or expose. Hide means it's the inside corner, and that'll actually hide the seam very well. And expose is an outside corner, which you're not going to hide the seam, but at least you can, at least it blends in a little bit. All right. What am I doing on time? Way over time, right?
Plenty of time.
Okay, so now you got to go into your infills, and there are tons of infills available now. I started looking at them, and it's crazy how many infills you have.
I don't see cat fill.
I'm sorry?
Shark fill.
Yeah. So I just showed a couple different ones. This is, well, right here would be rectilinear because you can't do 100% with the hex infill. And then here's the triangular infill. And then you got various percentages. I can't remember who did this, but I think it was Mike did a study on infill strength. I could be wrong on that.
CNC Kitchen has a really good one.
But what they basically found, I think, with most of these is that if you do your infill above about 50%, it doesn't really add to the strength of the part anymore. It just takes longer time. What does add to the strength of the part is your shell thickness or your wall thickness. And you go up 3 or 4, maybe 5 walls, and that's what's going to add the strength of your part. Simplify 3D also has what's called infill angles, and you can select, say, rectilinear, and then you start adding a bunch of angles. You can actually make it look like a triangular fill or like a octagonal fill if you add enough angles to it. But if you go and you set it up to have every angle on every layer, then you have to drastically increase your infill density, because it's going to give you a sparse infill, because it's going to put out more material. So I usually default on any kind of if I'm doing some kind of statue or figurine or something like that, I usually default to somewhere between 10 and 15% infill and set it up for rectilinear. And then if I need strength, I'll usually go with a triangular infill. Everything that I've read says that the octagonal might give you slightly more performance, but Shashi?
You need to say that the infill angle is rotating the angle of the infill on each layer.
So you can have, the question is, does the infill angle rotate on each layer? And you can set up Simplified 3D so that you can have, if you have 3 different angles, you got 60, minus 60, and what's it, 120, I guess? That sounds wrong, but it might be. Yeah, whatever it is, I don't know. You set up the 3 different angles. You can have it so that it'll print one angle on one layer, and the next layer will do another angle, and the next layer will do another angle. Or you can have it set up to print all 3 angles on a single layer. If you do more than 2, the odds are really good that when you get up to the top, you're not going to have the right angle to support your first layer, and it's going to suffer. So you're going to end up with things like pillowing. But yeah, you can do that. I don't know why you would, honestly.
There's a newer infill pattern on Cura called, I think it's gyroid.
Gyroid is infill, yes.
And that does that same function where it rotates as it's going on.
Yes.
Changes the angle.
Yeah, and I haven't played with infill that much. I know that the triangular infill gives a very strong part if I need a strong part, and it prints it fast. I've done the fast wiggle hex infill a few times. It shakes the printer a lot. I don't know if it produces a good part.
That's the same thing gyroid does as well.
Does it shake it?
I actually was printing something today and it was bouncing around a good bit.
Yeah. I typically don't like that because it takes more time to print the part. A lot of my parts I have to get out the door the next day when I print them.
I have a question about infill. Would you recommend using your Dizaro design software like AutoCAD or anything like that to create your own infill for punts rather than just using the printer's infill?
So the question is whether or not you'd rely on your CAD software for infill versus the printer's infill function. I would always use the printer's infill function. You're going to spend a long time. Now there are ways, if you need a specific area of the part stronger, there are ways you can take, and we can get at that at the very end. You can actually take and modify and make that area stronger in Cura. I don't think Simplify 3D has that function. But there are ways to do that. Simplify 3D, you can fake it, but it doesn't work quite as well as Cura. And the slicer, the Prusa Edition slicer, has that function as well. But yeah, I would never do the infill in my CAD software. Okay, moving on here. Outline over. Back up one more thing here. The shell wall thickness. So I found that anything over 4, which is usually corresponds to about 2 millimeters, your print starts to warp. So just be aware of that. That if you're having warping and you got lots of walls, even PLA will start warping on you. Just be aware that there is a point where it's too much.
Now that's millimeters and not number of walls you're talking about.
This is number of walls here. Sorry.
Number of walls.
Yeah, I wouldn't go over 2.5 millimeters thick on walls. And it's you're right. It's the wall thickness, because you have a thicker nozzle, then you're gonna have thicker walls. Unless you have a really big part, then maybe you can get away with it. The problem is that the plastic cools faster on the outside edges than it does on the inside. So if you have a large number of walls, you trap that heat inside. And so you have the outside edge cooling, and as it shrinks, it's going to either warp, which is most likely, or if you have the temperature turned way down, then it's going to delaminate, or if you have, it's just going to cause problems. So I mentioned pillowing earlier. Here's a picture of pillowing down here. There's all kinds of causes for that, but a lot of times it's in your infill settings that you change to fix your pillowing. So you have this thing called outline overlap in most slicers, and what this does is it causes you to put just a little bit extra plastic into the wall and tie it into your infill, and that gives you extra strength. If you're doing something like a statue, you probably don't need it, but I usually set it right around 15 to 20%. If you have it set too high, once again, you can cause warping because you got too much material and it doesn't cool. Your infill extrusion width. So I usually recommend that you set your infill extrusion width, your regular extrusion width, to 120% of your nozzle diameter. There's reasons for that I won't go into here, but unless you guys really want to. But sometimes if you want to go with a lower infill extrusion for some reason, if you want to save on material, you can go to like a 15% extrusion and then lower your infill width to 80%, and that's going to give you a higher density infill. It still takes as much time, but you can print faster sometimes if you're running into nozzle thermal issues where the temperature's not high enough to keep up. So you can take and decrease your width, increase your speed, and get your printer out the door faster. Question?
You mentioned setting the line width 20% greater than the nozzle.
Yes.
So that's the space in between passes.
So the line width
So
is.
you're allowing it to move sideways and merge.
So the question is the line width of 20% greater than the nozzle size? So the line width is what you extrude out. When you do a single extrusion, the width of that line is your line width. So if you have a 0.4 millimeter nozzle and you set your extrusion width to 0.48 millimeters, what it does is it takes and it squishes against the layer below it, and then it presses out, it expands out. And then you have usually a little bit of flat area on your nozzle, and that will take and iron it out, that width.
Now, does that interact with the line spacing on parallel lines?
So, no, it doesn't cause overlap on the parallel lines. It does not interfere with the line spacing.
Because I thought that line setting was, you make a pass, say at 0, then the next pass will be at 0.5 millimeter if you have a 0.4 millimeter nozzle and a 0.5 millimeter line.
Yes, that's correct. That will, so it will, I'm sorry, I thought you meant, yeah. Yes, it will cause it to be extruded out further apart.
Does it increase the plastic flow to make it?
It increases the plastic flow.
Okay, so it does both these?
Yes.
Okay, thanks.
All right, so I'm at 8:30, I'm way over here, so I gotta get through this here. Sorry. So extrusion width, you got minimum length, infill area, I'm gonna skip that. Combine infill every X number of layers. I usually set that to 1 because you can lead to problems later. I'm sorry? So if you have, say, a 0.1 millimeter layer height, and sometimes you can get away with putting your infill layer height at 0.2 or even 0.3. If you do that, you end up sometimes your top layer not actually touching the when it comes across, it doesn't have any support because it might be 3 layers below or 2 layers below. So I usually turn that off. It doesn't save that much time. It saves a little bit of time, but it takes a lot longer to reprint a part than the time you'd save. And once again, it can cause this pillowing effect if you have it set too high. Solid diaphragm, I'm just going to skip that. Gradual infill steps. Now this is something that actually is a really nice setting in Cura because you can start out with the 5% infill and go up to, it'll be 5% and then 10% and then a 20% infill. And it allows you to save a lot on your infill if you don't need strength in the part. But it does create a part that the strength might be kind of weird on that. It's going to be weaker at the bottom. So don't do that for mechanical parts. John, question?
You can take it on simplified.
I'm sorry?
You can take that simplified, same thing.
The gradual infill steps, yes, you can fake that and simplify using multiple, yeah.
Change infill. You can change infill type actually. You can
Yep.
have it create a step, but you
Yes.
can take that.
Yeah, so simplify can do that too, but it's not a setting there. All right. Where's a good time to stop, Shashi?
Let's go for, let's go through level 2 and we'll hold questions till the end.
Okay, all right. So this is print speeds. I think most people understand print speeds. The normal printing, that's your inner walls and your infill print speed. So people say they're printing at 90 millimeters per second. That's what they're talking about. The outline or the outer wall, I usually set that about 50%, and that gives you a really high quality outside print. The solid infill, that's your bottom and top layers. I'll set that to about 80% just to give you a little bit higher quality on that. You can go down to 50 if you have problems. Support structure speed, I usually print that at the same speed as the rest of my prints, but if your prints are getting knocked over, you want to reduce that to say 50 to 80%. Your XY movement speed, that's basically the limit of how fast your printer can move. I don't like to go more than double what my print speed is, and in fact, sometimes I'll just do 100 millimeters per second if I'm printing at 70. It doesn't really increase or affect your print time that much, and you can get quality problems because you're going to get overshoot when you run over to print something. And then your Z-axis movement speed, that's usually set to about 16 to 20 millimeters per second. You don't move that very much anyway. All right, and then speeding up. Supports. There's a lot of stuff you can do with supports, but the main thing you have there is your infill and your density between Cura and S3D. So if you don't know, set it to 20%. But you have an option of using dense support, and so you can actually set that to say 5 or 10%. and then increase your support as you get closer to the area that needs to be supported. And that can save you time and filament. You have this extra inflation distance or horizontal expansion, and I like to go beyond the part a little bit. Basically, so if you have a 20 by 20 millimeter part that needs to be supported, it'll go, you set it to 0.5, it'll do 21 by 21. It'll put a 0.5 millimeter extra support around the edges. And that, it just seems to give a better supported area. I don't know why. You can also combine your support every X layers, just like the infill. Once again, I'm not going to recommend doing that. You can do it. And then, like I said, you talked about your dense support interface. This creates a roof on the top or on the bottom. And especially if you're doing soluble support or dissolvable supports, you can do really high density support layer there. And it actually, the print comes out almost perfect. You can't hardly tell that it was supported there. And then the other thing I have here is your base layers or your brim. If you got really tall supports, I recommend turning this on. Otherwise, your supports can once again get knocked over easily. Okay, going really quickly here. Yeah.
What I would like to see is anyone familiar with any of these settings? Raise your hand. Awesome.
All right, so most people are familiar with these. Yeah, it should have. A lot of these are pretty basic, honestly. But all right, so I'm just. You know what? We're gonna post this online. Does anybody have a question here?
Questions at the end.
All right. So, Marlin linear advanced K factor. I'm going to stop after this. This is the first one I'm going to do, but I'm going to stop after this. So, there are retraction settings, there are wipe settings, there's retract while wiping, there's coast settings, there's all these settings that people do to compensate for the nozzle when it first starts printing or when it ends printing. It doesn't. The way Marlin normally does this is it's a linear thing. As you start printing, you start extruding, and when you get done printing, you're done extruding. And people have realized that when you first start printing, sometimes you have to have a little bit more material or a little bit less material, and when you get done, you definitely want to shut off the material before you're done because it keeps flowing after you stop extruding. So what they've done here, and starting with Marlin 1.1.6, and if you're not running Marlin, you're kind of out of luck. They introduced something called linear advance or K-factor settings. And what this does here, if you look at right here, you print this test pattern. And it starts out and it does a slow speed, and normally it does that pretty good. But then as you go to this fast speed, you'll see the line will get skinny, and then as it slows down, it'll get fat again, and then it does a slow speed normally. So what they've done is they modeled the filament as a spring, and the K factor is the spring setting of the filament. And they take your whole system and they assign a spring factor to it. And so it decouples your motion of your extruder from the motion of the movement of the head from the extruder. And what it does is at the very beginning, it can, if it sees a fast move speed ahead, at the very beginning, it can actually put out more material. And at the end, it'll put out less material. And if you do that, you can turn off your coast settings, you can turn off your wipe settings, you can turn off, all these crazy settings that we've done. And instead, what you do is you run this test pattern. You can Google Marlin linear advance, and it'll take you to this test pattern. It's a test pattern generator. It's amazing how much better your print quality is going to get once you turn this on, and most people don't do it. The other thing is that like TPU people always thought TPU was hard to print, right? And you got to print slow. I'm printing at 80 millimeters per second right now, and no problems, no stringing, nothing. So
Is it you turn it on in the Marlin firmware, and is there a matching setting over in the?
So you turn it on in the Marlin firmware. It's normally on, and then I can't remember the command, but if you go here, it'll tell you the command. You basically print this test pattern, and then you pick out the best one, and then you enter that number into your slicer settings, into your G code, and you're going to have different numbers for different materials. So if you do nothing else, go home and tune your printer using this. You'll be amazed, and turn off all your well, I still have my retraction set to like 0.5 or something like that, but you can basically almost turn off all your retraction, turn off all your coasting, all your wiping, all those crazy things you do to try to make things look better, and it virtually eliminates your Z-seam too. So, anyway, all right, we'll stop here since it's getting late. Question, yes. Right here?
I thought somebody back there had one first. Otherwise,
Oh, okay.
So, in Kira,
Mm-hmm.
it appears that there's a way to specify where you have and have not support beyond the support from the base only.
Yes.
And I saw a hint of that, but I couldn't figure out how to use it. And
It's
it wasn't in the instructions I could find.
yeah. So it might be easier to actually show you that on how to do those supports. In Cura, it's a little bit complicated, I think, to do supports compared to Simplify 3D. If you're going to buy Simplify 3D, you buy it because of the support, or the ability to do custom supports. Cura has that now, but it just doesn't work as good as Simplify 3D. I'm sorry.
What does it do as well?
Cura's custom supports just doesn't do quite as well as Simplify 3D.
Now, maybe some hidden instructions you haven't stumbled on yet?
Well, so in Cura, you have what you do is you tell it where you don't want supports, or you can use a support modifier.
Yeah, and I couldn't find instructions on how to do that.
I can show you after this. I think
Okay.
we're trying to wrap up here. There's one more question here.
Have you experimented with the tree supports very much?
I have used tree supports. They work okay. They're actually designed for SLA prints. They don't work quite as good as regular supports. All right. Sorry, I guess we should have turned this into 2 sessions. I don't know. But anyway.